simpler. Why are you sitting there? Clustering where is there? हाँ आएंगे तो बोलो वहाँ बैठ जाएंगे तुम लोग इधर आ जाओ ना going to be a little simpler than what we did in the previous classes, and we have discussed quadrilateral elements, right? And for that we went until defining the Jacobian and then finding out the B matrix, and then from that B matrix strain and stress and all those things, also stiffness. Okay, so today we're doing, and the way we do it for this kind of element, you can also do it for quadrilateral elements as well. What we'll do today. And it might so happen that the way we do today for triangular element, you might be asked to do it for quadrilateral element. Okay. So in quadrilateral elements we had shape functions, and we found out shape functions by using Lagrangian formulation. Right. The property of shape function is that the shape function defined at any particular node I, so ni at I, should have a value of 1, and it should always be 0 at other nodes. Okay, this is the property of a shape function. So, and it doesn't matter if it is linear or quadratic shape function, it must have a value of 1 at its own node, and it should have a value of 0 at all other nodes. Okay, so this kind of element, why do we need this kind of element? We can mesh anything with quadratic element also, quadrilateral element also. So why do we need triangular elements?
gap fill करनी.
Yes. So complicated shapes cannot be modeled. You don't really need to fill gaps using triangular elements, but you can do that as well. But you can also mesh the whole thing using only triangular elements. So two triangular elements can form a kind of quadrilateral also. Okay. So you can mesh completely with triangle, or you can take a combination of quadrilateral and triangular elements, and you can use that also. There are some problems with this element, and that's why it is called constant strain triangle element, CST element. And the reason is that the strain within the element cannot change. It cannot vary, it remains constant. So that's why the name is like that. We can't really use Lagrangian in this. Okay? We can't do that. Because we cannot define an epsilon axis and an eta axis, because there are 3 vertices of this triangle, and that Lagrangian method will not work in this case. So we need to find out shape functions by some other means. Okay? So let me name them, and suppose this is the base of the triangle, and let us take a specific case, a right angle triangle. Okay, this becomes the base and this is the height. Okay, so what will be the area?
Half HP.
And I want to find out a displacement. So suppose this node is getting displaced. Okay, and it can get displaced in any direction, it doesn't matter. But if it is very far from the base, then I am not changing the base. I'm changing the height. Okay. So the changes in this node can be described by the change in area, because area becomes a linear function of whatever change is happening in that node, right? Because B is not changing. Similarly, if I have to find out a displacement at a point which is closer to this node within this triangle, that I can do as a function of area. Okay. So any point within this triangle or this triangle will be defined by some combination of the area which is formed by this point. Okay. So now I have A1, so this is 1, this is 2, this is 3, so this is A1, this is A2, and this is A3. So by a linear combination of A1, A2 and A3, any point, this point can be here, and then I will be making 3 different triangles, and the displacement in that point can be defined as a function of some coefficient into areas, right? So then I can define the shape functions as the fraction of area which is formed by that point, because any point will be dividing it into 3 areas. Okay. So in this case, the shape functions will be the area fraction. Okay. And this is in absolute terms. So this shape function can be in local coordinate system, can be in global coordinate system also. So in global coordinate system, you can find out the area of the triangle from the coordinates you have. Okay. And then you can find out the area of the triangle which is formed by any point within that triangle, and then you can find out the shape functions in as a function of the global coordinate values also, right? So if I sum it, then this is going to be 1, right? So because there are 3 vertices, there are going to be 3 shape functions, and all of them are going to be 1 at the node they are defined and 0 at the nodes where they are not defined. Apart from that, I also get a condition that all 3 of them are not independent. So n1 plus n2 plus n3 must be 1. Right? So if I take n1 as epsilon and n2 as eta, then n3, there is really no need of third axis. The third one is simply 1 minus epsilon minus eta, because that is dependent. Okay. So in terms of local coordinates, I can define it like that. Okay. And when epsilon is equal to 1, then now you imagine height which is showing the value of the shape function. So this will be epsilon is equal to 1, and at other places it will be 0. And similarly, if you have eta is equal to 1 and so on. Okay. So now let me draw it again, and let us say I have node number 1, node number 2 and node number 3, and I will have here a displacement u1 and v1, and here I will have is this okay? It's a 2-dimensional entity, so you are going to have 2 degrees of freedom at every node, right? So, so this is also isoparametric element. So displacement as well as coordinate can be defined using the same shape function. Okay. So x coordinate can be defined as ni xi, so that will be epsilon, and so now let me also describe the coordinate values. So let us say this point is x1 y1, and x2 y2 and x3 y3. Okay. So this will be epsilon into x1 plus eta into x2 plus 1 minus epsilon minus eta x3. Right? You should also keep on writing. Don't just see, just also write. And if you want to think, you think. But I don't believe that you are doing that. So this will be N1, which is epsilon, into Y1 and N2 Y2 plus 1 minus epsilon minus eta, and what do I have? Y3. Okay. And I can write U as U1 U2 U3 and V1. So V is equal to V1 V2 V3. Okay. So far good. Everything is okay, right? Now what do we need to do? We need to find out strain. So for that we need to find out del u by del x, right? So strain matrix, and in this case we are not going to make those big matrix. So strain is simply del u by del x, del v by del y, del v by del x, and del u by del y. Okay. So I am going to find out these three terms for using global coordinates: x1, x2, x3, y1, y2, y3. Okay. So simply that. So now what should I do? So what is my Jacobian? And then you have del x by del eta, which is, can you check, is this or should I have del, well I can also do that. So I will have del x are done, so del y by del epsilon and del y by del eta. If this is not correct, then I can correct it. So if this is my Jacobian, then how do I describe del u by del x? So del u by del epsilon will be equal to what? So let me write it here. Del u by del epsilon will be del u by del x by del epsilon plus del u by del y by del epsilon, right? So del u by del epsilon will be equal to del x by del epsilon into del u by del x, and then del u by del epsilon. Sorry, this is del y by del epsilon. So this is correct. So this is Jacobian, and here I will have del u by del y. Right? So here I will have del u by del epsilon, and then I should have what? Del u by del eta also. So this will be equal to this into that. क्या नहीं किया?
दोनों यू है।
हाँ दोनों u है।
इसे वहाँ पर प्लस वाले टर्म।
नहीं वो y है, u जैसा लग रहा है। ठीक है? उसकी टेल थोड़ी छोटी हो गई। ओके? Now if I want to find out del u by del x, what will be that? Do I need Jacobian for that? Yes, I need to, because my u's are in terms of epsilon eta. So del u by del x will be, so del u by del x will be equal to what? Del u by del x will be equal to inverse of this into this, right? So this is Jacobian. So I'll have del u by del x and del u by del y. This will be equal to inverse of j multiplied by del u by del epsilon and del u by del eta. Okay? Is this okay? So in order to do that, I need to find out first, I will find out Jacobian, right? So Jacobian is that. So I need to find out del x by del epsilon, and I will find out all these things. Del x by del epsilon is equal to, so I have to do the derivation of this, differentiation of this with respect to epsilon. So this will be x1 minus x3, right? So this is x1 minus x3. Then I need del x by del eta also, maybe. So del x by del eta will be x2 minus x3. Do it, you do it. तो बैठे नहीं रहो, क्या करो, कुछ करो. No, it's not funny anymore. Every class we are doing something like this. और पिछली बार पेन गायब था, किसका पेन गायब था? किसी का तो पेन गायब.
I have pen. His pen finished. I am giving my pen to write something.
तो एग्जाम में भी दे दोगे?
Until I am not writing.
Okay. उसको तोड़ लो. So अभी अगली बार से ये सब प्रॉब्लम मेरे को नहीं चाहिए, ठीक है? तुम लोग घर से आओ, पेन लेके आओ. हाँ, सेना में लड़ने चलेगा, तलवार है नहीं घर पे, भूल गया. मैं अपना तलवार उसको दे दिया कि वो लड़ लेगा, फिर मेरे पास दुश्मन आएंगे तो मैं ले लूंगा, मैं लड़ लूंगा. ये क्या आ रहा हो रहा है क्या? So now you tell me what do we need now? We need del x by del eta तो हो गया, इसका तो हो गया. So we need del y by del eta and del y by del epsilon and del eta. बताओ क्या हो गया?
y1 minus
What?
y1 minus
Y1 minus Y.
y1 minus y3 del y by del epsilon.
yes sir.
Okay. So y1 minus y3 and this will be y2 minus y3. So we will use a shorter notation for this and we will call it xtuvm and we'll call this xtwmv. That's very bad group. No. So we'll call it x13 and we'll call it x23 and we'll call it y13 and we'll call it y23 because why not? कुछ समझ में आ रहा है तुमको? हाँ? तुम राशि लो, कृतिक ऐसा नहीं करना. लिखो, कुछ साफ है पूरा पेज. कहाँ लिखा है? क्या लिखा है? लिखो. ये क्या है? इसके आगे लिखो. क्यों नहीं डिफरेंशिएशन करो? स्कूल डेज का चीज है, मैं ही करूँगा अकेले. तुम करो. Now I will use pink, but yellow is looking good.